The purpose of this video is to shed a little bit of light on the dark art of putting balustrade onto concrete stairs, precast stairs that have been installed and site surveyed. And it's this model in particular which has prompted this video. This model was sent to me pretty much as you see it by a client who asked if I could just issue the balustrade for fabrication. One of the first things that I did was to compare what had been modelled against the sketched out site survey info. Now, the first thing I noticed was that all the angles of the stairs are all different, and they varied up to about 3/4 of a degree, a little bit more maybe, from memory. And the client's drawing office had set out the stairs to the survey, double checked that, and he'd done that correctly. However, this is not their field of expertise, and the draftsman had naively mimicked the angle of the stair on his balustrade. So he had lots and lots and lots of individual assembly marks for all these panels and handrails and posts even, etc. So in the end I commented on this and they said remodel it how you see fit. So that's what I did. I did an exercise of justification, which I'll get into in a minute. Remodeled all this balustrade so that you had standard panels to be issued throughout. In actual fact, the variation on the angles was so great that I ended up with about 3 different standard panels over the 4 staircases. Obviously you're always going to end up with individuals in your returns. Not that one, that's not a good example. The way that my client's drawing officer detailed these, he'd put his joint here in the middle, so nearly all these panels were all individual marks. I'd say every one, to be fair. So I scrapped all this information, made a copy of the model for the stairs, scrapped all this information and remodeled them elsewhere. Now the model that I'm about to open is actually same site, same job, just a different set of stairs. In fact, I'll show you. Don't save, don't save. So this is the fresh model. This is the model that I issued from, and once I'd done all my angle justification, void width justification and flight width justification, I set about remodeling it and completely changed the way that it would detail. If you recall the previous model, the one with the orange balustrade, the joint in the panels had been placed here, which meant it went from there to there, from there to there. So what I did, I approached it in a different way. Let me just turn off. So what I ended up with was this common panel here that basically went on nearly every flight. In fact, it might have gone on in every flight, apart from handing. These stairs are handed slightly different. But in effect, what I did here vastly reduced the amount of individual assemblies through the job. I'm just going to shut this model down. Very recently they've asked me to tackle another couple of stairs on the same site, and I've ended up going up and measuring it myself. The contract manager on this job, quite young, and he doesn't have a lot of experience site measuring, and I did this as a personal favour. I used to work with him. He was a draftsman in a drawing office that I used to work in. Came in as a trainee, done quite well for himself. He's now a contract manager, but he doesn't really know how to measure stairs up, and he knows that I've got a lot of experience with stairs, both fitting, making and detailing stairs. So I don't normally do this, but I agreed to go to site and measure these stairs up. So I went and measured both stairs in a day. So this is that stair. In a minute I'm going to show you how I detail stairs, but just going back to a little bit more history. 3 or 4 years ago I measured, this was a job in London, and there was several tower blocks with all these multi-flight stairs going up. I measured these in a format that suited me. What I find is that a lot of guys, they go to site and to measure stairs, and they put all their measurements on little plan views that they sketch out on site. The information comes to me and it's very hard to follow. The information doesn't translate very well sometimes from one flight to another, so you're struggling to set it out. It's very, very long-winded. You can spend an entire day just trying to decipher the site info. And the reason I don't like people measuring in plan or sketching in plan is because you shouldn't be drawing in plan. You should be drawing or modelling in elevation. So this is how I like my information set out, in elevation. So before I went to site to measure this job, bearing in mind I knew exactly how I was going to measure it, I pre-drew the stairs out in pairs of flights, and that has ended up, that's developed over a couple of years into this document. Now, what I've got here is it's for a typical dogleg stair. You can adapt it a little bit for stairs with short little infill returns. You can have wide voids, that's upper landing. So if you've got a couple of treads or a couple of risers going in there, I just sketch them to one side. But generically, these cover most concrete stairs. Primarily, we're thinking of like a side fixed stair. If you're fixing to the top of steps, you need a couple of extra dimensions. But if your palm plates are going on the side of your concrete strings, then this is a very good method of doing it. Looks very convoluted, but it isn't once you get into it. So I've numbered the pages. Number 1 is a top landing, because I start at the top of the stairs and work my way down. And what you have here is all these boxes. In the C box, before I go to site, I'll print these off. So I'll print one of those. That's the bottom 2 flights, and then if I've got 8 flights in between, then I'll print 4 of these and fill that in. So looking at a typical mid pair of flights, I put a laser line on. My own laser is 55mm from its base to its line. Project that on, and then what I do is, if I've got the information to hand, the AutoCAD drawing, the architect's AutoCAD drawing, or engineer's architect drawing, DWG, sorry, I'll pre-fill in all, wherever it says C, I'll pre-fill in. And the reason I do this is so when I go to start taking my own measurements, which is the S dimensions, I can see at a glance whether anything has been installed incorrectly or whether I've mismeasured anything, and it saves revisits back to site. It's not a be all and end all, but it does help. And if I've got that information and I'm measuring, or even if a client's measuring, I will sometimes pre-fill these in and then send them copies of these already pre-filled in. The red letters that you can see here is a reference to each measurement, and then you've got a similar set up on here which gives you landing back to nosings back to wall, width of your landing, width of your void. Now when I'm measuring, I put my laser on the top nosing. I don't put it on the landing, I actually put it on the stair nosing itself. Pretty much ignore landings because they can be a bit messy. And then I measure down this dimension. These are my crucial dimensions. Your nosing to nosing. Dimension from a laser line down to the top nosing. And then this dimension, I don't measure down to the point just below that stair. I cast it over till it picks up the nosing of the next flight descending. Like I say, the reason being is that sometimes this might be slightly higher than that one, and it ties up all your flights better. When you're setting them out in your model, you don't end up with these little gaps that don't quite tie up. And because all the information is set out in elevation, that's pretty much how I'm going to model it in my model, or draw it in AutoCAD or whatever. So you've got your right hand stair, and I've got a left hand ascending stair. That little sketch there just shows how you should set your laser up. So you measure down to that dimension, you don't measure that one, you cast over and you measure to that one, and you ignore that just in case you've got this scenario here where you've got a little step in your landing. You wouldn't believe how badly installed some stairs are. Well, even cast some really badly cast stairs. I've got this one as well, and this is basically a running dimension which I drop from the main landing down, and I take a running dimension at each full landing level, and that gives me a cross reference. When all these tot up, I should be within a few millimetre of this dimension. Unfortunately, these days they're so over the top with their temporary guarding that you can't always drop a tape measure down the landing from there like that. Now this sheet was prompted by the multi-flight stairs that I showed you with 20 flights in. What I would do is I would go through all these sheets and I would transfer all that information onto these. There's a little guide here that tells you what they are. I'm not going to get too in depth for it, but what I find is that once I've got all these filled in with the information from these sheets, I can literally model a stair from this one A3 sheet of paper. And I don't need to be flicking from page to page to page to page to page. What it also does is I can see, it also gives me a comparison of dimensions, and I can see at a glance if something's don't look right, if something's like jumping out at me, is like, why is that dimension? I can query it or check it. So you've got your running sight there. These are landing identifications. Right, I don't put sight measured angles in. I'll get to that in a second. So, like, see, there's your dimension from laser line down to your nosing this flight. So the A, B, C, D, they all relate to A, B, C, D, all these different red letters, and just like I say, it just gives me a tabulated view of the entire stair on one sheet, and I can just put these to one side, and I'm not flicking from page to page to page. So on here you'll notice that I've got an angle for the stair. I don't always measure the angle of the stair, and the reason I say that is if you take a 6 foot level to sight and drop it over your nosings and slide it up and down, you'll find that some nosings are high, some nosings are low. I've got a digital angle finder which I drop on top of my level, but it just adds to the site survey process. So if I'm a bit pushed for time, I don't bother with that at all. I just don't take them. Another thing I've noticed is that some guys, they put their angle finder on the soffit. That is a really, really bad practice, because you won't believe how badly cast some of these stairs can be. So that the dimension there, that dimension, can vary between top and bottom of a flight. So it's a false reading anyway. And the only reason I put it in, if I've got time, is it's just a cross reference. That gives me an idea that the stairs have gone in something like, if I know it's 30.2 degrees theoretical, the C value, and it's coming out at 34, I'm going to remeasure it, I'm going to flag it up as incorrectly installed. And believe me, some stairs are so badly installed it beggars belief. So that's pretty much the information that I work from. If somebody's asking me, can I model some balustrade onto concrete stairs, and they're going to measure it, I'll pretty much insist that they use this method. As I say, it looks very convoluted, but it's not. Once you get your head around it, or if you see one filled in, it isn't. It's a really good and methodical method. It also ensures that you get all your dimensions that you require, because if you've got an empty box, how hard is it just to glance over a sheet of paper and see if you've got any empty fields? The guy who's taking the measurements just needs to fill this box. You don't need to be aware of any of this other stuff. That's for me. All this information is mainly for me. I have put like descriptions of how it works and like the theory of it and everything, but it's not anything that anybody who measures stairs regular needs to get bogged down with. So I'm going to close that down. Save changes new. I use those sheets for this job, and like I said, there were 5 of these staircases with 20 flights in each. And over the 5 staircases, I measured all 5 staircases over a couple of days, and by doing that justification, using that big summary sheet, a couple of those big summary sheets, should I say, I could work out roughly what common angles were. Now you'll see that these stair flights they're in different colours, and they represent angles that match each other. So this. It's a bit of a weird one, this, because it was just loose glass. These are some temporary bracings that I introduced, so that the lads on site could go and pre-fit these posts and put these bracings in with shot holes in, and that would set them so that when they came in with the glass would match the post fittings, as the glass followed on weeks later, and that worked great. I don't think I had one single panel that didn't fit. I'll tell a lie, there were a couple of panels that didn't fit, but that's only because they'd been made wrong. It wasn't because I detailed them wrong. But out of the quantity of panels, that was pretty good going. So I'm going to shut that one down. Okay, so from that site survey information, I then end up drawing out the stairs in AutoCAD, not in Tekla. One of the things I'll say about just Tekla in particular, I mean, the information that I'm passing over in this video is applicable to concrete stairs, precast concrete stairs that you're going to be modelling or drawing balustrade to. But Tekla specific, well, there's a lot of videos on YouTube of people showing how you draw concrete stairs using Tekla's macros. To be fair, I won't even attempt to use those macros for this kind of application. The main reason being the information that it requests from you is not the information that you're picking up side. Putting in your rise and going gives you nothing, absolutely nothing on to work on, because that is not the information that's going to be coming back from site. No matter what you're doing, the information that Tekla asks for is not relevant to a site survey stair. This is probably all what I've never used. I don't use them, I just don't entertain them whatsoever. They're just too long-winded. But if you're modelling concrete stairs as a concrete manufacturer or as an engineer, etc., then they're probably all well and good. But for this application, where you've got a load of dimensions coming back from site, the information that you should be receiving back from site is not relative to Tekla's macros. The information that you want from site is information that I've displayed on this and on those site survey sheets. Okay, so back to these two bits of information here then. So this is the two stairs that I've recently been down to measure up and detail from the client who sent me the badly modelled balustrade to the 4 staircases. So I've adopted the same principle where you've got a mid panel which is copied in these 2 staircases. By the time I'd done my justification, which I'm going to get into in a second, this mid panel was the same for this entire stair. This is an opposite end stair, so basically that panel got repeated for every flight, and then you just get variations at the ends, mainly due to the fact that the void lengths vary. So how do we go about doing this then? Bring back to this AutoCAD drawing. This is the stairs set out in AutoCAD as it was surveyed. When I'm doing this, as I go along, I'll just put my laser line on. I draw it as I measure it. I start at the top, work my way down to a ground. Put my laser line on, and using the survey information, I then put in using my survey information, I set out the stairs. What I'll do is I'll drop a circle in here at this point to that dimension. I'll copy that line down. By that dimension. Draw a line from centre of circle down to the bisect of those 2 lines, and then I use the divide tool, and that puts me points on, and I just put a few horizontal lines on and just basically use a polyline to draw that flight in, and I just repeat that. It's not a quick process, and you think, well, I could be doing it in Tekla, but what you find in Tekla is working with construction lines and points. When you've got that many construction lines and points, it's so messy. It's unbelievably messy, and I just don't like doing it that way. I find that I've got much more control over this. It's easy to check because I can see all the dimensions. Every time I regen or redraw, those dimensions stay there, whereas in Tekla they disappear. So it's quite hard to do multiple flights in Tekla. If you've just got a couple, that's fine, but when you're working with multiple flights like this, it's just a bit of a nightmare. So I do this in AutoCAD, and it's not just for drawing the stairs as well. So once they're in, I'll go through and I'll check all my dimensions and make sure that they match all my information on my survey sheets or the supply survey information. And then the next thing that I'll do is I'll go in and I'll put the angle in to 2 decimal degrees. to 2 decimal points, sorry. And I'll do that all the way through. Because I've got the information for 2 sets of stairs, I will tot up how many angles there are, and then tot up the value of each angle, tot them all up, and then divide by the amount of angles there are, and that gives me an average angle. So my next step then is to, just if I turn my dims off a minute, and put on the baseline surveyed angle. I'll turn my laser off. So that is the, it's like a theoretical, if you like. As I explained before, these nosings will be all over the place. I'm just switching my dimension on again. Just a point to notice, this is a palm plate type balustrade that's going to fix onto the sides of the stairs. The positioning of the palm plates will float around a little bit. I will not give a dimension from nosing to awls. What I will, actually, I'm going to get into that in a second. I'm digressing a little bit. So if your brief is for surface mounted posts, you pretty much need to add an extra survey dimension down to which posts, which treads you think you're going to be fixing to. It needs to be specific. You cannot use this because on site that nosing could be 10mm away from that line, which means that that surface there, or this surface here, won't be where you expect it to be. It could be high or it could be low. So you need to predetermine which treads you're going to be fixing post to, and then measure down to each one individually, even if that means you've got 2 or 3 additional dimensions on your surveys, which is just damn sketching, to be fair, onto those generic survey sheets. But most stairs that I do are side fixed anyway, so it works perfectly for that situation. So once that's modelled in, just going back to that, turn off my dimensions and my laser. You've got this theoretical line. Theoretical line, there you go. So what I've done is, on the centre of each of these pitch lines, I've put this is a 1000mm 1 metre line. The top of the handrail on the rake is going to be 1 metre, so I've made it 1 metre long, and I've copied it from the centre of each one, again for both sets of stairs. What I then do is then I draw in another line, I use a construction line, horizontal, and then I just rotate it to the average angle that I've worked out, and that's not my baseline justified angle. There you go, and that's it. And you can see it's floating a few mil above the top nosing, and it'll be an equal amount. It's 1 mil on that one, and it'll be an equal amount below at the bottom, and that's fine. That's absolutely fine. The rule of thumb for stairs is if it looks right, it is right, and they will look right. And the theory is that you just work around the centre of your pitch line and put that in. So if I just turn off the the surveyed baseline, you end up with these. If you just float over, you see that it's acceptable. You'll see straight away. Sorry, it's there actually, so that's even more acceptable. These are pretty good, these stairs. They were only within like less than half a degree of each other, so compared to the other 4 stairs that I did on this site, these are quite good, which is a bit worrying because they're currently fitting those other 4 stairs, and I know they're having problems, which makes me think that they were badly measured. These are quite close to each other, and like I say, the other 4 stairs, they were more than 3/4 of a degree difference over the stairs. Right, so that's that information. The next thing that I would do is I would then offset this line by 1000 mil, and that eventually will lead me to just balustrade set it out to this. Now, because I'd already drawn that job once, all I did is I just took a copy of the Tekla post and just inserted it into here. And it's because it's got this weird crank on it, it just gave me my intersection point for handrails on returns. But if that hadn't been there, then it's just a case of working that bit out in your actual Tekla model. So the basic information that you need to put in is your handrail, centre line and outlines. Then I've got a common dimension of 80 mil from underside of rail to top of shadow rail. Same again there, 80 mil. I've got I'm sticking with a common dimension from top of the shadow rail. That's the same, it's 978 for every flight on these 2 stairs. And then this one comes in wherever it comes in. So by drawing it out here in AutoCAD, it just keeps everything simple, it keeps everything neat. I can stretch stuff around, and once I'm happy with that, I'm happy that everything flows through nicely and meets nicely, that this bolt distance is the same, your handrail heights are the same. I've got my plasterboard drawn in. I will then close these down and do a save on that. Open one model up. I'm just going to shut all my modelling objects down. Best way to do this is just turn parts and mods off, I think, for a minute. And that's pretty much what I get to come in. And I using a contour plate. I've already decided that from the survey information, I've already decided that all the width of the flights were all within 10mm each other. This job in particular worked out well because all the handrails fits on saddles. All the balustrade is fixed, it's just riveted, the handrail is riveted to the balusters, so it's just been supplied in prefabricated lengths, which are over length, and every one I've been told to make slightly over length, and they've got guys on site and they're going to fit these, cut them to suit, and weld the joints and put filler in. This is a hospital, so all the handrail joints need to be seamless. People are putting their hands on, they don't want them being places for germs building up. So the handrail's got to be continuous with no seams. So that works out quite well for this job, because what it's meant is that I've gone through my survey information, I've looked for the widest landing, and I've made them all the same width. The void, same with the voids. Went through the information, looked at all the void widths, which only varied by 5 to 10 mil, and I've set that as my widest, and it's a common void width for all these stairs. It just gives me more repetition. It simplifies everything. Let me just turn that stairs on actually. I'm just going to turn off object group. I'm just going to, let's just have the concrete on. Okay, so you'll notice then that I'm filtering by phase, and the reason being is just for simplicity. These aren't issue phases, they're just a modelling phase. I tend to do this a lot on jobs. If I've got grating, if I've got balustrade, if I've got like primary steel work, put them in different phases, like me existing, that's typically I'll put existing or dummy stuff in phase 99, all my slabs and everything in phase 101, and then everything I'm issuing is in these first three phases. So once I've modelled all these in, I'll then go back to my AutoCAD drawing, to my reference model, and I'll switch on the justified balustrade set out and the 1000mm vertical baseline. I'll do a save on that. Now I don't need to shut it down. I've done a save. I can leave that session open. Go back into my Tekla model. Open my reference model list. Select that reference model and reload all. And that has brought in this. Now that gives me a permanent tracing to work to, and that is literally all that I do. Just move that from one side to another. When I'm doing the wall rails, I'll just copy it or move it over to that side or this side and just keep repeating that process. You actually get through these quite quickly. Once you've done this tracing, once you're happy that it's all set out, everything's at the correct heights and intersections are nice and neat, they're not like missing or incorrect in any shape or form. Once you're satisfied with that in AutoCAD, you bring this in. I can model the basics of this stair very, very quickly in Tekla, whereas without the AutoCAD, it's a very long-winded process. And as you can see, everything overlays that DWG reference model perfectly. And that's good to go. This is a typical GA that I've sent to my client, and this is what the guys from site will be working from. I've got a 3D one as well, which has all the mark numbers on, but as far as setting out is concerned, they're gonna set their landing panel. I'm going to set that to this information here, just a few side drillings. That's all they need for that. And then they're going to mount the central void posts, which are loose. Mount a central void post, which is loose. I'm going to bolt the three panels together, and then literally just going to suspend them in between, and then pull up on the middle. It's going to sag. When you do that, that's going to sag, and they're just going to pull that up till it's at the theoretic level or till it looks okay, and then put a single fixing in there, and then just follow up with the rest of the fixings, and they're going to continue with that. As I've said, because these nosings are all over the place, I can't give a dimension from that nosing or any nosing down to a bolt hole. It's just not feasible. So basically they're working to this 85 here, and they're working to a 968, not 978, to the top of the tab on their posts in the void and at the top landing. Well, this one floats around due to the distance from the tread to the edge of the return voids, and on this particular job I've added a 5mm shim in it, and they'll just put these posts in on loose nuts, and that should give them the option. All these have got slotted holes in the tab plates. That includes on the return posts, So I'm expecting these stairs to fit quite cleanly. I'm not expecting any phone calls whatsoever. Typically this is how I would present my plan views. Start off with a section key. All my section arrows are there. You'll notice that I've given these are the floor levels. I start at level 2, 2.1, 2.2, 2.3, level 3, level 4, level 5, roof level, etc. And that should relate to these. So these plan views are a lot easier to follow than a lot of the architect's drawings that I get, because it shows the floor level, the mid landing level. I put a number on for the stairs. I don't number every step, it's ridiculous. So just number 1, right, that's your top step. Because of the way that I've modelled it, it looks like you've got an extra step in here. So I repeat the landing level number and just do all that the way through until you get to the top floor. 108, 108, 96, 96, 96, 96. And that should be quite easily to follow. Some typical details of how it's all fixed together. So that's the plan view, and then we also have the typical marking plan. Looks like it needs an update on it. That's just how I've named everything. So I've done all the balustrade panels on one side, the inner handrails, the inner handrails in another view, and the outer handrails in yet another view. And that's pretty much all the information that we've had for each step. Right, I hope that's given you a little bit of an insight into concrete stairs. Please share with your guys that are measuring stairs the fact that you want the information in elevation, not in plan. Thanks for watching.